If somebody wanted to show that cognition penetrates perception, what evidence might they be inclined to cite? One thing that is even today still cited is an old study by Bruner and Goodman. Bruner and Goodman were interested in the idea that perception undergoes variations when you're hungry, in love, in pain, or solving a problem. Interesting idea. And their famous case study involved the perceived size of two types of object. On the one hand, objects with social value, they chose to use coins, and on the other hand, very similar objects with no social value, they chose to use cardboard discs. They had a very simple paradigm. What they would do is present the subjects with a particular coin and then ask them to adjust the size of a spot of light by adjusting the aperture through which the beam was shining to match the size of the object they were seeing. So they have an object that's a certain size, they're looking at that object and simultaneously adjusting a beam of light so that the spot that light makes should appear to the subject to be the same size as the object. They did this experiment with 10-year-olds, 10-year-old children. And what they found was very striking. What they found was that subjects were pretty accurate for doing this with the cardboard discs. That's the dotted line that you see here. They're pretty accurate there. But when they're doing this with coins, they think those coins are really quite a bit bigger. And as the coins increase in value, so does the discrepancy between the actual size and, according to these results, the perceived size. Even more excitingly, these very exciting results, Bruner's always got some brilliant idea. Fascinating. Even more excitingly, these two found that if you look at the poor children, they did exaggerate the size of the coins. Sorry, these are the rich children. If you look at the rich children did indeed exaggerate the size of the coins, but the poor children exaggerated the size of the coins far more. They're the top line. And Bruner and Goodman took that to further support their idea that the value of something can influence your perception of even its very basic features, like its size. This is an important result because it inspired a large body of research. But I want you to pay careful attention to what follows in the next section before you make use of this. There are some things I'm not telling you right now that I'm only going to tell you later. And if you miss those things, you're going to fall into a big old bear pit. And you wouldn't want to fall into a big old bear pit, would you? No, you wouldn't, Steve. No, good. Don't fall into the bear pit, okay? Pay attention. The next section's called Evaluation and Conclusions. Stay with me for that, because if you stop here, you're only getting half the story. So here is a first piece of evidence which suggests that the apparent social value of an object can influence its perceived size. This is a good example of evidence that has often been cited to support the view that cognition penetrates perception. And I think that this is evidence that points us very clearly in that direction. What about another piece of evidence, though? You wouldn't want to base a case on a single piece of evidence. I mean, that would be mad. What we're really looking for is evidence from using different paradigms from different labs. Multiple. The more variety we've got, the more confident that we can be. So the second piece of evidence comes from Witzel and colleagues. Witzel is one of my favorite researchers. He's incredibly careful. I mean, it's absolutely stunning when you read some of his work, how careful he is in the way that things are experimentally controlled. And Witzel is also very, very careful in drawing conclusions, as you'll see. Now, this team has a very interesting idea. They suggest that because sensory signals always contain uncertainty, combining evidence with prior knowledge is a useful strategy to constrain perceptual estimates. Why do I mention this? Well, you might be thinking, is there some kind of theoretical reason to expect that cognition would penetrate perception? And this is it. This is the reason. The perceptual inputs, the information that your senses get, is quite limited. And relying just on that information always involves large amounts of uncertainty. So it makes perfect sense that other information that's available to you, or from things that you're not currently perceiving, but stored in you, should be used in order to unravel, reduce the uncertainty involved. Makes perfect sense. So the idea that cognition penetrates perception is far from being some kind of like mysterious, quirky idea. There's a very good reason why we might, in theory, expect that to happen. Now, the case study I want to share with you involves colour. And you might think, well, it's a little surprising, Steve, that we're talking about uncertainty and colour. How much uncertainty could there be if you were looking right at an object? Let's say it's a nice banana. You're looking right at the object, about the colour of the object. How uncertain could you really be about the colour of this beautiful yellow banana? Do you know what? I'm going to go and get you a banana. Just a second. So this here is my banana. You're looking right at the banana and you're thinking to yourself, Steve, I couldn't really be more certain about the colour of that banana. Couldn't really be more certain about the colour of that banana. Well, actually, the information that you get about colour is often quite difficult to decode because, for example, if you change the light sources under which you view the banana, perhaps you're inside under some electric light, or you go outside and it's early in the morning, or it's the middle of the day, or it's later in the evening, all of these conditions, it becomes cloudy or sunny, it's shady, all of these conditions are going to change the information that comes to you from the banana about the way that light is reflecting off the banana. So actually identifying the colour of the object, the yellowness, for example, of the banana, is a pretty difficult problem to solve computationally. And so it's actually a case where there can be significant uncertainty about the colours of objects. Very good. So case study involves colour. It makes sense for us to study this as an example where there is perceptual uncertainty which might be filled in by your background beliefs. And here in particular, we're going to focus on a phenomenon called memory colour, which, as far as I know, was first studied by Dunker all the way back in 1939. Now, what Witzel has done recently is a beautiful and simple experiment that actually you can do right now. So what you're going to do is, first of all, look at these two discs. They're both discs against what ought to be a completely grey background, and you're going to tell me which one matches the background. Is it this disc here, disc A, which is grey like the background, or is it that disc there, B, which is grey like the background? Or if you don't think either's grey like the background, which one do you think is closer being the grey of the background? Is it A or is it B? Now, take a look at these two. Which of these two bananas do you think is closer to the grey of the background? Is it A or is it B? When Witzel ran this experiment, what he found was, just as you'd expect, that most people are right about the discs. They choose the grey disc over the disc which actually has, as it happens, a slightly bluish tint. Whereas, as Witzel predicted, significantly more people were tempted to choose the slightly bluer thing in the banana case than the actual grey thing. Why did Witzel predict that? Well, in earlier studies, when he'd done some much more careful work, he'd shown people pictures of bananas against grey backgrounds and then asked them to null the colour, to remove the colour from the banana by adjusting a slider until it matched the grey background. And what Witzel found was that people actually removed too much of the colour, so they went past the grey into the complementary blue in order to eliminate the yellowness of the banana. Now that was a good way of doing the experiment because it eliminates various kinds of bias. this procedure, which is called nulling, so getting rid of the colour, eliminates various kind of bias, and it results in people having a slightly too blue banana. And the idea that Witzel and colleagues proposed was this: when people are encountering a banana, their perception is a function both of the sensory information and of their antecedent beliefs, the beliefs that the banana is yellow. That makes this banana, if you like, extra yellow. So in order to bring it down to grey, it's not enough to actually remove the colour. You've got to go a bit further and introduce some element of blue, some complementary element, in order to really counteract the yellow which is contributed by the belief. So there's some yellow which is contributed by the sensory information, there's some yellow that's contributed by the belief. To get rid of both of them, when the belief remains constant, you've got to not only eliminate the sensory information, but go a little bit in the opposite direction. And that's why Witzel predicted here, correctly, that people in the case of the banana would be more likely to say that the banana was matching the background when the banana was a little bit too blue than when it really did match the background. So what you see here in the banana case is that, first of all, people are picking B significantly more often than A, and secondly, that is significantly different from what they're doing in the case of the discs. And if you go back and look at those images again, you can probably see for yourself that there is a kind of perceptual difference there between the greyness of the bananas and the greyness of the discs. So I like this. I think this is a marvellous demonstration. This isn't the most careful paradigm. If you want the careful paradigm, you have to take a look at the Olkenon et al. Paper that Witzel was also involved in, which is in the list of readings for this section. If you want the most careful demonstration, go here. But I like the one that Witzel has done with these pictures, my banana pictures, because this is something that you can quite plausibly see yourself. So you don't have to just rely on the statistics. So I think that's a simple and powerful demonstration. But Steve, is there some more evidence? That's a very good question. So if we rely on 2 studies from 2 labs, that's quite good. They're independent. They use different methods, different age groups. Well, I'm quite happy, but more is always better. We really want to be able to pile this on. But this isn't actually entirely different. So it's not exactly the same, different paradigm. We're still using the method of nulling out in order to make something neutral across the next study I'm going to show you and the one I have just shown you. So the study that I'm going to show you now, I'm actually not going to show you, because if you remember when I was introducing the questions in lecture 1, I already introduced you to this experiment by Levin and Banaji. What they did was they took a series of faces that their subjects could easily categorize as either white or black by race. So this white and black term, of course, refers to race, not colour in this context. And they also adjusted the lightness of these faces. Then what they asked subjects to do was to compare faces that might be drawn from different racial categories as the subjects identified them with respect to the lightness. And they demonstrated, just as I showed you before, that subjects thought that in order to be matching, the black face had to be lighter than the white face in reality. So they had to make black faces a bit lighter, white faces a bit darker in order for those to match. What this suggests once again is that your cognition penetrates your perception. Your beliefs, in this case about the race of a face that you are seeing, is influencing how light or dark you perceive that face to be. So apparently, your beliefs can influence your perception of size, colour, and lightness. If that's true, then we have very clear evidence for if that's true, then we have very clear evidence for the penetration of your perception by your cognition. Your perception is not just a matter of sensory inputs and the principles which are proprietary to perceptual processes, On the contrary, other things that you believe or know, your thoughts, can influence the way that you perceive the size, the colour, and the lightness of things in the world.